Okay, so welcome to all of you. Today we will see the method of false position to find the root of the equation. So this is the second method. So previously we have seen how to solve the equation with the help of bisection method. So today we will see how to find the roots of the equation by using method of false position. Okay, so now the method of false position, it is also called as linear interpolation method or regular Falsy method or method of chord. Okay, so why it is called method of chord, that we will see. Okay, so by this method we will find the root of the equation f of x is equal to 0. So first we will find the interval. So last time we have seen with the help of the bisection method, but for the bisection method we have found we are finding a and b such way that f of a into f of b less than 0. So we will find the root, we will find the values of a and b so that f of a into f of b is less than 0. So your a is, I have taken this as xk minus 1 and xk. Okay, so that f of this into f of xk, f of xk minus 1 into f of xk is less than 0. So this is what, so this will write neatly. So this is f of xk minus 1 into f of xk is less than 0. Okay, so these are the points. Now this is what xk minus 1, this is the value of x and this is the value of y now. So f of xk minus 1, q xk minus xk and f of xk, these are the 2 points on the curve f of x is equal to 0. Okay, so now the your function is continuous. Now draw pq. So we have drawn this three, your p is this, your q is, we have drawn, we have just draw a chord pq. So this is the equation of p2. Then we know that this is 2-point form. This is the 2-point form, y minus y1 upon y minus y1 upon y1 minus y2, x minus x1 upon x1 minus x2, right? So that is the formula for a 2-point formula. So with the help of 2-point formula, we have find the equation of the, so we got the equation of the chord pq, right? So 2-point form. So remember this is 2-point form. Okay, the root of the f of x is equal to, that means what, this is the point of intersection of the chord and x axis. Okay, so this is the next root of the f of x is equal to 0. Okay, so so this is what, then so for this is what intersection with the x axis, and on x axis your y is 0. So you put y is equal to 0. If you put y is equal to 0, then this will be removed. Now this y will be 0. Then this is minus of f of xk. So what I did, xk minus 1 I have shifted here. Then x minus xk remains here, and xk I have shifted here. See, xk I have shifted here. This is minus f of xk. So minus f of xk is directly. Just I have shifted this xk minus 1 to this side. So this is xk minus xk minus 1 upon this. Okay. So this is what, therefore what, the next approximate is what? So I am calling this as x at xk plus 1 is xk minus 1 upon this. So in terms of a and b, if you want to write this formula in terms of a and b, so I will call this what, xk minus 1 as a. So this is what, here f of xk. This is what, f of xk. Okay. So xk plus 1 is this. So I write xk minus 1 is equal to a and xk as b now. So then your formula is what, the next approximate root is what, x1 is what, so xk minus 1. So b minus f minus b minus a upon f of b minus f of a into f of b into f of b. This will be your formula. Okay, so this is your formula now. So we'll simplify this now. We'll simplify this. This is what, b f of b minus b f of a minus b f of b plus a f of b upon f of b minus f of a, f of b minus f of a. So this is equal to, what is this? Then this is a f of b minus b f of a upon f of b minus f of a. Okay, right? So you may write, if you want to write this formula, you can write this formula also in the form of, if you want to write f of b, b f of a minus a f of b. See, this is what upon. So f of a is the plus side. So you have to write f of a minus f of b. Then your second term is f of b has a negative sign. Give the negative sign to this one. Both the formulas are correct now. Okay. So you can take any a and any b. Okay. That means you call this as xk minus 1 and a, or if you call this as b. No problem for this one. This will be the formula. This will be the formula. And into what here? Okay. So yes. So we can write this what? Okay. So this is your formula. Suppose what here f of x1, you have to find f of x1. So if it is less than 0, if it is less than 0, then see which will what? Suppose f of a is greater than 0 or f of b is greater than 0, then root lies between x1 and a. If f of b is greater than 0, then root lies between x1 and b. If it is less than 0. If it is greater than 0, check the previous one. Which one was the, this is what greater than 0, which one was the less than 0. Then same as the bisection method, you have to choose a and b now here. Okay. So once you get the interval, you can call this as first as a and first as b, no problem for this one. So for the iteration method, you will find a second root now. Then you have to find second root. Now here what? Suppose your x1 and this is what a, suppose root lies between. You can call this as b now. x1 is b now here. Then this will be a now. Just you can put here. We can put here now. Okay. So no problem. You can do this with the help of the iteration method. Bisection, same as the bisection method, you can find the next a and b now here and apply this formula for a and b everywhere now here. Okay. So I hope that you understand this one, how to apply this. So see that. Okay. So here what it is depending. We'll take a problem. Find a real root. Find a real root to correct to 3 decimal places of the equation f of x is equal to x cube minus 3x plus 1 is equal to 0. Plus 1 is equal to 0. Plus 1 is equal to 0. Okay. So now what we'll do, we'll find first a and b now. So f of first we'll find f of 0 now. F of 0 is 1. What about f of 1 is 1 minus 3 plus 1 is minus 1. So f of 0 is less than 0 and f of 1 is greater than 0. We need the functional value here now. For bisection method we don't need the value, but here what we need the value of the function. Okay. So in bisection method just we are checking only that it is positive or negative, but here what we are checking it is positive or negative also, and we are using that value also. So here what the value is also important here. To find function value is also important here. Okay. So therefore root lies in the root lies in 0 1, where I have taken this interval now here. Okay. Or you can say this is what root lies between 0 and 1. You can say this one. Okay. The next approximate is what? X1. So this is what? A into what? 0 into f of 1. So just I will write the formula. This is what? X1 is equal to a into f of b minus b into f of a upon f of b minus f of a. Anything, any formula you can write. You can write b f of a in minus a f of b upon f of a minus f of b. Whatever, there is no problem for this one. Minus 1 into f of 0 upon, so you have what? 1 f of 1 minus f of 0. We'll put the value here now. So this is 0 now, no problem for this. What is f of 0? Is 1. So what is f of 1? F of 1 is what? Minus 1. So this is what? Minus 1 upon 2. So x1 is minus 1 upon 2. Oh, this is minus 1. Okay, f of 0 is 1, so minus 1. This is plus 2. I will write this as 0.5. I will write this as a 0.5. Okay, so I have to find the value of f of 0.5 now. F of 0.5 is what? 0.5 cube minus 3 into 0.5 plus 1 is equal to. So what is this value? Minus 0.375. Minus 0.375. So you have the scientific calculator, can find it. This is what? This is less than 0. This is less than 0. So now f of 0.5 is less than 0, and see in the previous one which was the greater than 0. So your f of, here we have written wrong now here, f of 0 is what? Greater than 0. This is greater than 0, and this is what? Less than 0. Where to take the care now? Okay, where to take the care? F of 0 is 1, it is positive, and f of 1 is negative. Okay, so that is less than 0. So now we have to check which one was the positive. F of 0 was positive now. F of 0 was positive. So 0. Okay, so therefore root lies in. So I write this. You have to write the interval. That means you have to take care which one was the less. The less number should be the first one, and the biggest number will be the second one. Now, if you want to write in the interval, okay. So if you don't want to write in interval form, you can write just between, and this is allowed now. You can write first 0 and secondly 0.5, or first 0.5 and 0. That we can allow right for. But if you are writing the interval, then this number should be the less than this number. A should be less than B now here. Okay. Okay. So next approximate. The next approximate root is, this is what? X2. So now your A is this and this one. 0 into f of 0.5 minus 0.5 into f of 0 upon f of 0.5 minus f of 0. Okay, so this number is 0. This is what? Minus 0.5 into f of 0. F of 0 is 1, no problem. So minus 0.5 upon f of 0.5. F of 0.5 is what? Minus 3.7 or minus 3. This is what? Minus 0.375 minus f of 0 is 1. So this value is x2 is positive here. So the value of x2 is 0.3636. 0.3636. See, your x1 is what? 0.5. This is what? 0.36. 0.36. Okay. So now you have to find the value of this one now. Just I am writing the polynomial here. This is what? X cube minus 3x square plus 1 is equal to 0. Okay. So, okay, now we find the value of this one. F of 0.3636. This is what? 0.3636 cube minus 3.3636. Is it square? No, this is square is not there. Square is not there. 36 plus 1. Okay, you have to find the value of this one. So the value of this one is minus, this value is minus 0.428, and this is less than 0. This is less than 0. So this is less than 0, then which was the previous one? So therefore what? Just we write this is what? 0.3636 is less than 0, and see the previous one which was the greater than 0. So f of 0 is greater than 0 now here. F of 0 is greater than 0. Therefore root lies in 0.3636. You are going approaching to 0 to 0. Okay. So now your x3, next approximate is what? X3 is what? 0 into f of 0.3636 minus 0.3636 into f of 0 upon f of 0.3636 minus f of 0. So this is equal to. So f of 0 is 1 now. So this is minus 3636 upon. So we have got this value. This is what? Minus 0.0428 minus f of 0 is 1. So this is value. So now this value will be the positive now. This value will be the positive. Because what? All are negative here. So this value is positive, and this value will be this value will be 0.3487. So what is your x2? X2 is 0.36 now. Up to 1 decimal places we get this one. Okay. So just I am writing here your x2. X2 is what here? X2 we get minus x2 we get 0.5, just 0.5. Okay. So now x3 is what? Just I am writing here. X2 x1 is here what? 0.5. X2 is what? 0.3636. 0.3636. Now x3 you got just what? 0.3487. Just I am writing the value of this one. Okay. Now we will find the value of this f of point x3 is what? 34. This is what? 3487. 3.3487. This is what? 0.3487 cube minus 3.3487 plus 1. Just you have to type this what? Just type bracket this number, bracket complete, cube minus 3 bracket this bracket complete plus 1. Right as well now here, and just write equal to. So you get the value minus 0.0037. Now this is negative. Okay. So now your f of 0.3487 is less than 0, and just previous one this was the greater than 0. F of 0 greater than 0. So therefore root lies in 0.3487. Now we will find the next approximate x4. So this is 0 f of 3487 minus 0.3487 into f of 0 upon f of 0.3487 minus f of 0. So this is equal to, this will be 0. Now f of 0 is 1. So this is very simple. This is 1 upon this value. We got this value is what? Minus 0.0037 minus 1. All are negative. So this value is positive now. This value is positive. This value will be x4. This value will be 0.3474. So your x4 I will just write here 0.3474. See, up to 2 decimal places we get a value. We get a correct value up to 2 decimal places. See, this is what? 0.34, 0.31. So this is what actually we got up to 8 decimal, up to 3 decimal places they want actually. So we get up to, this is what 4. If this is what greater than 7 or this, then up to 3 decimal places we get. This is 4. So if this is 5 or greater than 5, then this will become 8. Then up to 3 decimal places they are the equal now. So we'll do one more iteration now. So we'll find this f of 0.3474. So this is what? 0.3474 cube minus 3 0.3474 plus 1, and this value is minus 0.003. See, this is less than 0. See, this is less than 0. So therefore f of 0.3474 is less than 0, and f of 0 just previous one this, yes, right? So therefore root lies in 0.3474. Okay. Now we find x5 now. x5 is equal to, so 0 into just 0 into f of that one, this into this. Okay. So f of 0.3474 minus 0.3474 into f of 0. So 0 into that one and that into f of 0 upon, and just you have to write this as it is now, 74 Just call this as 1 now. 0. So we write the values of this one. This is 0. So minus 0 point, okay, 0.3474 upon this value we got. This is minus 0.003 minus 1. So this value we got. This is also positive value. This is positive value. This is also positive value. No, this is not. This is value is negative. This value is negative. So now this value will be okay. This will be positive. Okay, no problem. This is not actually. This is not a functional value. Okay, so we are correct now. 3473. Okay, so now our problem is what? Correct to 3 decimal places. Okay, so therefore this is what here. Your x4 is what? 347 now here. This is 347. So up to 3 decimal places you got the correct value. Therefore the desired root is x is equal to 0.3473. Okay, now stop here. Up to 3 decimal we get this one. Now stop the iteration now. So up to 4 decimal places if is a, then you have to do the iteration now. Okay, up to 4 decimal places. That means what here? 4 decimal places should be equal. Okay, so now here what? To consecutive iteration, the first three decimal places should be the equal. So here what? So in x5, x4 and x5, these are 2 consecutive iterations. So their first 3 decimal places are same. So your whatever the last one will be your desired root. Okay, so this will be the desired root. Okay, so we'll do for next one. Find a real root. Find a real root of the equation f of x is equal to x tan x plus 1 is equal to 0 in 2, 3. For trigonometric functions, if possible, they will give you the interval now. Okay, correct to 3 decimal places. 3 decimal places. Correct to 3 decimal places by using, in the exam the method will be explained to you by using the method of pause position. In exam the method will be produced to you. Okay, so if method is not given, there is so many problem will be arise. Okay, solution f of x is equal to x tan x plus 1 is equal to 0. This is your f of x. Okay, so here a is equal to 2 and your b is 3. Whatever this you can take, you will take a is equal to 3, b is equal to this, no problem for this one. So but interval will be ba now there. Okay, now x1 is equal to, okay, so first you have to find the value of f of a and f of b. So f of 2 and f of 3. So it is very difficult to find this. So f of 2 will be f of 2. So with the help of the scientific calculator, your calculator should be, see what, there is the mode now. See the calculator, where is the mode? Press it up to we get degree and radian. Right? Okay, so the digits are given here 0 and 1. Okay, so if it is where is the radian, it is 1, or if radian is given 0, just press 0. So your calculator is converted into radian measure and then find the value of this one. Okay, so see this value, whether you get this value correct or not. with the help of your scientific calculator, your f of 2 is minus 3.3700. Okay, we'll take only the consider 4 decimal places. This will be less than 0. And f of 3, we need this f of a and f of b, right, for this one. So f of 3 will be 0.5723. Just you have to type 2 tan, just tan is there, tan is what? Tan 2 plus 1 equal to, you get this value. Check whether this is correct or not. Okay, so now x1 will be what? Then x1 will be what? Root lies in 2 and 3. Okay, so 2 into f of 3 minus 3 into f of 2 upon f of 3 minus f of 2. So this will be 2 into, what is this? F of 2. F of 2 is what? Minus, you have to take the care of the sign of 2. Minus 3 into, minus, oh, this is f of 2 actually. You have to write the value of f of 3. So f of 3, you have to write the value of f of 3. What is the value of f of 3? F of 3 is 0.5723 minus 3 into minus 3.37. You may drop that double zero. You may write only the 0.37 also. Okay, upon, what is your f of 3? 0.5723. I write here plus now because this value is negative. So 3.3700. How with the help of the calculator? Just write bracket. Then 2 into bracket. This figure you have to write. This figure. Then minus 3. Write bracket. This figure along with the minus sign. Bracket complete. This is bracket for the numerator. You have to write a bracket for this one. Okay. So that means what, for the calculator you have to draw like this. First find the numerator in bracket and then also divided by, then write the denominator in bracket. So divided by, and whatever this in bracket. So don't forget to close the bracket. If you are opening the bracket, don't forget to close the bracket also. Okay, in bracket draw this one and just click on equal to, you get the value of this one. Okay, so I think this value will be 2.8548. You check this value. Okay, so now we'll find f of x1 now. That means f of 2.8548. So I will write the value here now. So x1 I got 2.8548. Up to 3 decimal places you have to do this one. Okay, now we'll find the value of this one. So this will what then? 2.8548 tan of right in bracket 2.8548, then plus 1, right, tan bracket this, then plus 1, and the value I got this value as 0.1581. I got this value. So this is greater than 0. Now which one was the less than 0? F of 2 was the less than 0. F of 2 was less than 0. So f of 2.8548 is what? This is greater than 0. And f of 2 less than 0. Previous one was f of 2 less than 0. Therefore, this step is very important. Root lies in, which one was the less? This 2 was the less. Okay, 2.8548 now. Okay, so now we'll find x2 now. So x2 is equal to what? 2 into, just 2 into f of this one. F of 2.8548 minus 3.3 minus 2.8548 into f of 2 upon f of 2.8548 minus f of 2 minus f of 2. So this is equal to 2 into, just write the value, 2.85, this is what? 1.1581 minus 2.8548 into f of 2. What is f of 2? Is negative value. So minus 3.3700 upon this value is what? 0.1581. This value is there. Just bracket, just write the value of this one. Minus minus become plus now. 3.3700. Okay. So now this will be. So I will directly find the value of this one. So you do this one, right? Just write a bracket. 2 into this minus 2 into minus 1, write plus here, plus this into this. Just close the bracket. Close the bracket. Okay, don't write this bracket now here. Just write one. So this into this. Or don't write bracket now. Just bracket to multiply. Multiply by this one. Minus 1 become plus. Plus this into this. Just complete the bracket. Don't forget to complete the bracket for the numerator. Then divided by. Just write the bracket now here. You have to write the bracket divided by bracket this plus this. Bracket complete and just press equal to. So you will get the value. You will get the value 2.8165. 8165. So your x2 will be 2.8165. Okay, up to 1 decimal places we get the correct one. So we'll find f of x2 now. So f of x2 means f of 2.8165. So this value is just I have calculated this value as 0.0507. This is positive. Okay. So f of 2.8165 is greater than 0, and which one was the less than 0 just in the previous? F of 2 is less than 0. F of 2 is less than 0. Okay. So that means what here? Root lies in this one was this 2.8165. Okay. So now we'll find x3 now. Just what? 2 into f of 2.8165 minus 2.8165 f of 2 upon 2.8165 minus oh, not this is f of, okay. So f of this minus f of 2. So this is equal to 2 into 2 f of this is what value we got? 0.0507 minus 2.8165 into minus 3.3700 upon 0.0507 plus 3.3700. Okay. So I got this value as x3. I got this value as 2.8044. This is your x3. So I write as x3 here. x3 is equal to 2.8044. 8044. Okay. I will find the value of this f of 2.8044. So what I got this value? I got this value as 0.0168. This is positive. So f of 2.8044 is greater than 0 and f of 2 is less than 0. Just previous one what? Just previous one which was the less than 0, f of 2 was the less than 0. Therefore root lies in root lies in 2.844. Okay. Now x3 you got. Okay. x4 we'll find out. x4 2 into f of 2.8044 minus 2.8044 f of 2 upon f of 2.8044 minus f of 2 So this is equal to 2 into f of 2.8443 got 0.0168. 0.0168 minus 2.8044 into minus 3.3700 upon 0.0168 plus 3.3700. So this value we get, this value you get, this is 2.8004. Your x4 is what? 2.8004. See, up to 2 decimal places we get the correct answer. We get the correct answer up to 2 decimal places. Okay. So we'll do one more iteration. We'll do one more iteration. So we'll check whether this is correct or not. Correct or not. Okay. So now so now find f of x4 now. Find f of x4. So f of 2.8004. So 2.8004, the value is 0.0056 and this is positive now. So f of 2.8004 is positive, and see the which one was previous one? F of 2. F of 2 is what? Less than 0. Okay. So therefore root lies in 2.8004. Oh, this is wrong. This is wrong now. You have to write interval, that means you have to write 2 first. Okay. So smallest one will be the first one. Okay. Root lies in this. Okay. Now we'll find x5 now. So x5 is equal to 2 into f of 2.8004 minus 2.8004 into f of 2 upon f of 2.8004 minus f of 2. Okay. So we got this value. I hope you understand this one. How to draw this value? Just write all the things. This value will be just I got this value as now. This is 2.799 now. So 2.x5 is equal to 2.7990 now. Okay, now here what? The x4 and x5 is not correct up to 1 decimal also. You have to find an x6. Okay, so with the help of this one, just use this one. I will tell you what are the values of this one now. Your x6 is 2.7986. Then your x7 is, you have to do this iteration. x7 is 2.7984 now. Okay. So next 2 iterations you will get the correct up to 3 decimal places. So therefore the desired root is 2.7984. Now see, up to 3 decimal places we get this one. Okay. Consecutive 2, right? 2 consecutive roots, 2 consecutive approximate roots are correct up to 3 decimal places. Then stop your iteration. Okay. So this will be value. So I hope that you understand how to apply this regular policy method. This is what here. This is also just same as the bisection method. But bisection method is very easy now. You have to take the mean of that one. But here what? You have to use the formula now. So that means what? If your root lies in A and B, just you write A, B is B minus B f of A upon this is what? F of B minus f of A. Or you can write this is what? B into f of A minus A into f of B, just A and this one. Okay? A, B, this B and this is this. This is what? F of A minus f of B. So if f of B has minus sign in the numerator, then f of B should have the minus sign at the denominator also. You take the care. If you write here f of B minus f of A, answer will be wrong now. You get all the wrong answers now here. So you have to take the care of this one. Just remember the formula. The formula is very important here. Okay. So if you go see here, what happened if you like this one? Numerator as f of A, f of B, and this is AB, right? So now see, this is also formula work now here. So this formula is also work here, but f of a minus f of b. You can remember the formula in terms of determinant also. In the numerator, what f of a, f of b, a, b here only. See, a here, b here, right? In this way also you can remember the formula now here. See here, if you multiply this one, b, f of a minus a, f of b upon f of a minus f of b, right? So you also remember like this. You may write this formula as f of b, f of b. So this is what f of a. This is b, this is a numerator. And denominator is what? F of b minus f of a. Your denominator is f of b minus f of b. Both the formulas are there. Okay. So this is the regular policy method or method of position. So problem is that you should have to solve the problem so that you understand the method now here. So okay. So how many iterations you have to do? So that is not. This is dependent on the problem. How many iterations you have to do? But if the problems, if the root lies between given, this is what 2, 3, and do the 4 iteration or 3 iteration is given. 3 iteration means what? These are the 3 iterations. x1, x2, x3. Do the 3 iterations. If the problem is like this command, so do the 4 iteration. 4 iteration means what? x1, x2, x3, x4. These are the 4 iterations. Okay. So you have to find the value of x4 now here. Up to x4, you have to stop here. If the problem is not asked like that, so up to 2 decimal, up to 3 decimal places. If the problem is in terms of the iteration, then what? You have to do this 4 value, find the value of x4 now, and then stop. That will be your desired route. Okay. So I hope that you understand the method of false position here. We will stop. Okay. Thank you.